Hi there and welcome to our lecture on changes of state. This is States 2 of Unit 2. So our key ideas for this section: what happens when a substance changes from one state of matter to another, and what happens to mass and energy during physical and chemical changes. So to answer our first question, the identity of a substance does not change during a change of state, but the energy of a substance does change. So it's not so much that the substance changes. If we talk about solids, liquids, and gases, the substance at the molecular level is still the same, but energy is going to change. So looking at this slide, if we start with a solid block of ice, when we increase the temperature, the solid melts and becomes a liquid. If we continue to increase the temperature, or the temperature continues to increase of that liquid, then it will evaporate and turn into a gas. The reverse process from going to a gas to a liquid is referred to as condensation, and then the reverse process of melting is freezing. We do have another stage where a solid can go to a gas directly. We typically see this with dry ice, because dry ice is solid carbon dioxide and it does not have a liquid state, so it goes from a solid to a gas by process of sublimation. So some of these changes of state do require energy. The changes of state that require energy are melting, evaporation, and sublimation. And evaporation is the change of state from a liquid to a gas. Sublimation, the process in which a solid changes to a gas. And we see this more in like dry ice type of situations. Energy is released in some changes of state, whereas if we are freezing or condensing, then we're actually releasing the energy to go to that state of matter. So condensation occurs when a gas goes back to a liquid, freezing when the liquid goes to a solid. So we're slowing down the molecules at the molecular level, which requires the energy to go somewhere else, and typically that energy is going to go out to the system. Whereas with the other transitions, we need to increase the energy, we need to put the energy into it so that the molecules will start moving faster and spread apart more. So to define condensation, change of state from a gas to a liquid. So here is a graph to indicate those energy losses, energy states in these different, for water we're looking at here. So as we increase the temperature from 20 degrees to 0 degrees, we are in a frozen state, or in an ice state, or solid ice here. So in order to move from ice to a liquid, we do have to gain energy. And then from a liquid back to ice, we lose the energy or give off the energy to our surroundings. So as the liquid increases in temperature and gets to our boiling point, or changes from a liquid to a gas, then we do get an energy gain. So the energy has to be gained in order to move from a liquid state to a gas state. And then from the gas state to a liquid state, we have to lose some of that energy. So we have to lose it to our surroundings. So our next question: what happens to mass and energy during physical and chemical changes? Mass and energy are both conserved. Neither mass nor energy can be created nor destroyed. So we have the conservation of mass and conservation of energy laws that are kind of summed up in that one statement there. So again, we're saying mass cannot be created or destroyed. So in chemical changes as well as physical changes, the total mass of the substance undergoing the change stays the same before and after. And that's the law of conservation of mass. So if we took a match and put it in a vial and then maybe put the lid on. We've got a fixed amount of mass within this container. If we take the cap off quick, light the match, put the cap right back on, and the match burns some, well, the mass within this container is still the same as it was in this previous container, even though we have a chemical change that took place. Some of this mass is now within the container as carbon dioxide and water vapor. So the byproducts of a combustion reaction is what we have here. So some of this mass is not in the solid state that it was with the match. It's now in a gaseous state. So we can say the same thing that we said about mass with energy. It's not going to be created or destroyed. So energy can be changed to another form during a physical or chemical change, but the total amount of energy present before and after the change is the same. That's the law of conservation of energy. So most of this energy that we're talking about that is being lost or is going to a different place is typically lost as heat to surroundings. So, thanks for listening.